Hello everyone, welcome to my channel Chem Insider. In today's video, we are going to discuss about one more reagent which is important for a reduction process, or you can also carry it out for the conversion of preparation of alkanes, and it also has some certain applications of forming a five-membered ring given the reactant provides all the required conditions. That is tributyl tinhydride. So in the complete video, we are going to discuss tributyl tinhydride and the applications of tributyl tinhydride. So whenever I'm going to write down the reaction and the reagent tributyl tinhydride, I might be writing TBTH. So don't get confused with tertiary butyl tinhydride. So this is tributyl tinhydride. So how do we write? What is the chemical formula of tributyl tinhydride? The chemical formula of tributyl tinhydride is Bu3SNH. Bu3SNH. It is a very specific reagent which is majorly considered for the conversion of a nitro group into an alkane, alkyl halide to alkane, or in order to bring about a substitution process of hydrogen, something like that. Say for the example, tertiary tin butyl, it is usually considered for the reactions such as conversion of RNO2 to RH. We might convert RNO2 to RH, or you can also convert ketone to alkane, etc. Something like that. So how do we prepare tributyl tinhydride? So we prepare tributyl tinhydride by treating them with tributyl tin chloride and lithium aluminum hydride. When you carry out a reduction process on tributyl tin chloride using lithium aluminum hydride, we prepare tributyl tin hydride. Here N indicating that this butyl group is in a straight chain. Okay, don't get confused with these tributyl groups. So tributyl is nothing but we have CH3, CH2, CH2, CH2. So these groups three times. Tributyl means N-butyl. Okay. So normal butyl group with three molecules of butyl groups attached to a tin chloride. When it is treated with lithium aluminum hydride, we obtain Bu3SNH. So this is our reagent tributyl tinhydride. Now, what are the applications of tributyl tinhydride? Tributyl tinhydride, as I already said, it is used for carrying out reactions of conversion or converting alkyl halide to form alkane. It is a first type of conversion which is basically used. Second type of conversion is it converts RNO2 group, that is a nitro group, to alkane. It also converts a nitro group to alkane. Next, the third important conversion of this reagent is converting keto group into alcohol, like this. And a very important example, that is, or very important application of tertiary tributyl tinhydride is bringing about a formation of five-membered ring. If the reagent has the conditions required for this particular process, then tributyl tinhydride can bring about a five-membered ring formation in the given reagent. And the last important reaction is bring a carbon-carbon coupling process. So if industrial cases, it will always involves the formation of carbon-carbon bonding or coupling reactions, this reagent can also be used for bringing about a carbon-carbon coupling process. Now let us discuss about the basic 2 or 3 examples, and in the next video we'll be discussing more about certain examples which has a more complicated reaction taking place. Let us start with the first one. conversion of alkyl halide to haloalkane. If you observe carefully, we have written TBTH, that is nothing but tributyl tinhydride with AIBN. So what is this AIBN? It is a side reagent which is used along with the TBTH, which also brings about which is also helpful for the conversion of alkyl halide to alkane. So what is this AIBN? This AIBN is given the name bis isobutyronitrile. Bis isobutyronitrile. The structure of this compound bis butyronitrile is we have a nitrile group N double bond N at the center, and it is attached with a butyl group, that is CH3 and one more carbon over here, but this carbon is attached to a nitrile group again triple bond N. Next on the other side, it is in the same manner CH3 C triple bond N. So this is the side reagent used for this reaction. Now let us discuss about the mechanism of this process. The mechanism of this process gets initiated because of the presence of nitro group present at the center, which tries to leave the complete molecule in the form of nitrogen. The mechanism of this reaction takes place through a free radical formation. So the bonds between the carbon and the azode nitrile group breaks down to form two carbon free radicals of the type C dot CH3 C triple bond N, along with the loss of a nitrogen molecule. Once this carbocation or a carbon free radical is formed, tributyl tinhydride Bu3SNH, that is tributyl tinhydride, attacks the species in the same again in the free radical form. As a result, the carbon free radical formed in the reaction attacks the hydride free radical formed, leading to the formation of N triple bond C CH3 CH3. After this, the free radical of tributyl tin we have obtained attacks the reactant of this reaction, that is an alkyl halide group RX. So once this free radical attacks the species, we obtain an alkyl free radical R dot along with the formation of tributyl tin halide, which is then treated with the hydride which was released through one more molecule of tin hydride BUSNH, leading to the formation of RH. Okay, so this is the mechanism of reacting alkyl halide conversion to alkane. So this conversion of alkyl halide to alkane takes me through this mechanism. So I'll explain this once more. Observe carefully. So first the mechanism starts with the processing of bis isobutyronitrile. So therefore this is the driving force, or we also call it as a side reagent. This breaks down the bond between carbon and the nitrogen groups present already in a double bond through a free radical mechanism. As a result, we obtain a carbon free radical. So this carbon free radical attacks our reagent tributyl tinhydride through a free radical mechanism again, leading to a formation of tributyl tin free radical. So this tin free radical attacks the halide group present in our reagent alkyl halide, leading to a formation of alkyl free radical, which later in turn attacks the one more hydride present in the tributyl tin, leading to the formation of alkane. Next, if you observe certain examples of this reaction, and there are certain phenomena, what is, if you have stereochemistry of alkyl halide present, what happens is once the reaction is done, there will be stereochemistry retention of the configuration. The stereochemistry of the compound will be retained without no changes. That is because this process involves di-addition. First, the alkyl group will be reacting in order to form a free radical. Therefore, the free radical formed in this process will be since there is no particular stereochemistry explained in the free radical, then what happens is it usually takes place the initial type of bond which is already present. So therefore, the product which is formed after the free radical formation will be having the same configuration as of the initial reactant. Now in the second example, we are having multiple halo groups and we have given excess amount of tributyl tinhydride. So therefore, the product will be a complete reaction where we have replaced or substituted all halogen groups with hydrogens. Hydrogen over here, we have hydrogen here, one more hydrogen at this position and one more hydrogen at this position. So this is the reaction of tributyl tinhydride in the conversion of alkyl halide to alkane. In the next video, we'll discuss more about the 4 other applications of tributyl tinhydride. I hope you have understood the mechanism of this process. This mechanism of treating tributyl tinhydride in the presence of AIBN is quite same for all the other applications also, except for the reduction of tertiary tin except for the reduction of ketone, where we use a hydronium ion water, that is protonated water. That is because we need to prepare alcohol but not alkane. If you have to prepare alkane in that particular example, what you have to do is you have to just use the tertiary tin butyl in an excess molecule. Okay, so this is about for today. I hope you have understood this video. If you have any doubt, please do comment down below, or if you have any doubts in other examples, you can mail those examples to me, which I have to the mail address which I have provided in the description box. Thank you for watching.